मैं complaint किया था कल. I don't know why they didn't take anything. This happened even before as well. Recording. अच्छा हाँ ठीक है. Okay, so you can see that this is the stream. And then stream API basically gives you a bunch of functions. Okay, now we'll see what these functions do. Just know that list is just a carrier. It's just a bucket. Stream is a bucket and bunch of filters. Okay, think of it like this. What I'll do now is I'll teach you these things. I'll teach you map, flat map, filter, and distinct. Okay, but I'll actually take you through this example. Let's say that I have the list. I want to find out all the numbers that are completely divisible by 2. Okay, so how do we do that in stream? I'll get rid of this. I'll say dot stream. Then you have something called filter. Okay, filter function, if you see, it takes in it's a predicate, and remember what we discussed yesterday. Predicate consumes one value and returns a boolean. Okay, so if you pass a function in filter, this will first check for the condition whether it's true or not. For every element that the condition is true, it will dump that element into the next segment. Okay, what do I mean by that? Here I'm going to say, I'm going to write a lambda function val. Okay, then this, and we'll say val ampersand, sorry, modulo function 0. Okay, when I do this, you can see that I get another, like this function here, it basically returns me a stream of integers. So anything called on stream will always return another stream. Okay, guys, give me 1 second. It's a bit too noisy. Okay, sorry about that. Okay. So filter function is something that takes in a predicate. Okay, and in predicate, you're basically, it has a function. If you click on this thing, you can see that it takes a predicate, and if you go into the predicate here, you can see that they have one unimplemented method called test. Test here consumes one method and produces a boolean, which is why it's a predicate. Okay, and you can see this functional interface annotation here. Okay, so what we do here is in the filter function, we pass the value, then we basically give our, we write the function which will return a boolean. Here I'm saying that anything that is completely divisible by 2, just give it this thing. Okay, now this gives me another stream, which means I can run another filter on this thing. Okay, or I can do something else. So what is the next step that I have to do? I have to find out the ones that are unique. Okay, so for this, what I can do is, you have a keyword called distinct. You can see this. Now, if you look here, distinct also gives you a stream of integers. So this is kind of like chaining function. Stream, if you call any function on it, it will always return you the stream itself. Like you can go inside this method and you can check the return type. It is stream of this thing. So you're calling a function on the object. Huh? Is this? Okay. You're calling something on this particular object, stream object, which returns you itself. Okay, so that's why we have all the functions available here. Okay, with this you can actually do a what do I say, you can chain up different functions. Okay, so here what we'll do is, we'll say distinct dot, then what is the thing, we have to basically convert everything to a string. So remember, this filter was for just filtering out the elements. Distinct was for finding out the unique elements. Then for us to convert data type from one to another, we have to use the function called map. Okay, so what I'll do here is, I'll say dot map. If you're confused, don't worry, I'll explain this again. Okay, in map, it again takes a lambda function val, and all I have to do here is I can write this return plus val, basically convert it to a string. I can either write this, or You can just have this. If you don't have the return statement, it'll take it anyways like this. Then what I want is I want this, because this again gives me a, you can see that this map gives me a stream back again. Okay, so I keep getting stream every time I complete a function of stream. From here, I can say that I want all of these functions to become a list. So there is something called collect. Okay, this collect here gives you, so in Java, you have, if you are working with array, then there is a library which provides all the functions that you can work with the array. Like if you have array and you want to do sorting on the array, then Java has a library for doing this thing. So the convention of Java is, if you are working with array and it gives you functions inside one class, it will be called arrays. Okay. Similarly, if you're working with collections and it gives you some library to perform, like work with collections, it will be collectors dot this thing. Okay. You can see here, I will basically pick this thing, collectors dot to list. Okay. This will be the end of my statement here. And you can immediately see that it says the result of stream.collect is ignored, which means I'm not capturing it anywhere. So what I'll do here is I'll say final list. This time though, if I say integer, okay, this will break. Why will it break? Because you can see here the error message. It says required type is list of integer, which is this, but the function is producing list of string, which means at this point, you have converted your data. Okay, I'll explain one by one, so don't worry. Okay, let me just show you what we did here. And now I'm just going to print this. I'll say after array, yeah, after operation. Okay, final list. Let's see if it worked. Huh? Nothing is there. Okay. Before operation, we have these. Acha, after operation, I forgot to add a new line here. That's why the confusion. So you can see, before operation, I had these elements 1, 2, 3, 10, 13, 53, 55, 56, and then 0. What was the next in line? It basically filtered in all the elements that were completely divisible by 2 and filtered out all the elements that were not completely divisible by 2, which means after this step, only those values were left which were completely divisible by 2. What are those? You have 2 here, you have 10 here, you have 56, and you have 0. Okay, because 0 is kind of considered the neutral number. Now what I did here was I said find out all the distinct elements. Okay, so it filtered out the distinct elements, but there was no distinct element. So let me go ahead and just do this. Let me add 10 once again. All right, so now I have at least one element which repeats. Let me run this thing. Okay, you can see that I get the same result. Even though there are 2 10s, I get this result. 56 again, because 56 is this thing. And this is all coming out as string. Okay, so let me explain what happened here. I took an example where I was given a list, a normal list of integers. Okay, and I had to perform 3 operations on it. First operation was that I had to filter out all the elements that were not completely divisible by 2. Okay, this was the step. In the normal Java coding way, I would have to write a for loop. I would have to, filter out all the elements and then added them to a list. Then to find out the unique elements, okay, I would probably have to write another for loop, or within the same for loop, I would have to apply my unique logic there and then convert everything to a string. Okay, so this much you would have to do in that particular step. Maybe if I just write it down, right, maybe people would understand. So let's say I'll say final list. Okay, this will be just a string. Okay, str list. new array list. Okay, the old way of doing it would be for, I'll use for each. So I'll say I list. What do I do here? First thing I will check if the I is, acha, now we have to actually, yeah. So let me remove the final. I'll reuse this thing. Okay. List teacher and let me say filtered list new array list. Okay, what I'm doing here is if I is completely divisible by 2. Okay, I'm just saying filtered list dot add, and then I'll just add the I here. So now after this step, I have all the filtered items. Now I have to basically find out the unique list. So go ahead and create one more integer unique list. You get new array list, and then I'll say for each integer, for finding out the unique list, I would have to use a hash map. Okay, so I'll say map integer. No, never mind. I'll have to use a set. Okay, so I'll say set integer set. Actually, I don't need this at all. Okay, new hash set. Okay, and what I'll do is I'll just keep dumping the elements. So I'll say integer I filtered list. Okay, I'll say set dot add, and then I. This will give me all the unique elements. Okay, what's this? Replace it with bulk collection all. Okay, done. What can I do? Replace with can be parameterized. Okay, that's it. So hash set would add, it would take in this filtered list, and then it would give me this set object. Okay, then from this set I would have to convert them to a string, which means I would have to run another this thing, and it will be integer s set, and I would say str list dot add. What do I want here? Plus s. Okay. After this, after all of these operations, this one here, this one here, then this one here, then this one here. After all of these things, I will have the list of string which contains all the numbers which are completely divisible by 2 and they're unique. Okay, and they're also converted to string. This is a very tedious process, and like it looks very small in here, but when you start coding in a company, you'll see that they have many such functionalities, and it will become very verbose. So in order to reduce the number of code, would they introduce the stream API? You can see that this entire chunk of code, okay, is reduced to just one single line. Okay, so now let me explain what is happening one by one. Okay, let's see. This is my original list. Okay, so I cannot work with list because list is just a simple bucket. I need something that is a bucket and filters. Okay, enters stream. Okay, now after I have converted to a stream, I can now start applying my filters. Okay, as in I can now start applying my operations on the stream itself. So here what I'm doing is I'm calling a filter function. Okay, what is a filter function? The filter function basically says that I am a function where if you feed me a value, I'll give you either a boolean, I mean either a true or a false. Okay, it is basically a predicate functional interface. Okay, so here we're passing the val, and then we're basically saying that everything that is divisible by 2 equals 0. So it will basically run this condition. Okay, it will run this condition, and for every value that this condition runs true, it will basically put them into a stream. Okay, at the end of this operation, there is no for loop here. You can see that there's no for loop where you're going over the elements again and again and again. Okay, stream API, what it does is as your element becomes available, it runs this again and again. Okay, so you can consider stream as like a pipe, okay, like a pipe of water. You don't have the water stored in the pipe itself. As the water comes from the tank, the water becomes available in your bucket. So the stream keeps running as your elements become available. Okay. So what happens is this particular part will run for as long as there are objects in this first chain of the stream. Okay. Then once this is done, it will then move on to, it will give you a stream of integers. Okay. Then you move on to the next function, which is distinct. This distinct, what it does is it basically, it has this internal mechanism where it is going to find out all the elements that repeat, and it will remove those elements from that stream, and it will give you a stream which contains only unique elements. Okay. So our second part here is also done with this. The next part is converting the data type. So I began with a list which was of integer. You can go and check, this was of integer. So I began with a list that was of integer, but in here in this map, I am allowed to do some operation which will determine what the next type would be. Okay, let me repeat that. In map, I can perform operations which can convert the data type. So after the map operation, okay, this here, it will still return a string, but it is not sure what it will be. It could either be an integer, it could either be a long, it could either be a string. That depends on this function here. So at the runtime, the compiler decides what type of return value it is. Okay, because if you now see here, right, so far, you can see that it has super predicate integer. If you look here, sorry, no parameter here. 1 second. If you see this dot here, you can see that it basically, the distinct here returns a stream of integer. Okay, but the moment I press a dot here, you can see it gives you a, you can see here, it already tells you stream of string. Okay, so this conversion from stream of integer here in this highlight, if you, I'm not sure if you can see it, but this stream of integer to stream of string, it is happening in the map place. So map is where you can actually convert your data. You can actually do all sorts of operations. But remember, it is not for filtering out your information. Filtering out happens in the filter element. So if you're feeding integer to filter, filter will give you integers back. If you're feeding filter, sorry, if you're feeding integer into distinct, distinct will give you integers back. But if you're feeding integer into map, map cannot decide at the compile time what the return type would be, and it will be decided only during the runtime. Okay. After this is done, what I'm doing here is I'm saying I'm using this collect function. Okay, collect function, what it does, it basically zips all the things. Okay, it takes all the streams and converts it into a list. So you, at the end of the operation, you have a list, which means you started with a bucket without filters. You then converted everything into a bucket with filters. Then when you're returning it, you got a bucket, but this time you have all the elements that you needed. Okay, are these steps clear? If you have any confusion, let me know.
Sir, map is only for doing operations to the data, sir.
Correct. It is only, you're only supposed to mutate the data, or mutate the data type. So what you can see here is I'm mutating the data type, but I could have had something like this. Okay, the moment I do this, okay. What is that?
Sir, we use print instead of printf. Is valid or not?
Which one? Which one?
In this case, print we use instead of printf. So we use print.
Do you know what the difference between print ln and printf?
Yeah. Print ln and printf I know, but printf and print no, don't know.
I didn't get it. Printf and println, you know.
Print ln and print I know, but
printf, acha printf, ठीक है. Okay, let me explain. It'll just take 2 minutes. ठीक है. So print ln, what it does, it adds a new line. Print, what it does, it adds new thing. But let's say you want to print something like this. Hi name, you have won a lottery of, okay, these things are called placeholders. Okay, that means your this entire message remains same, static, but these values are changeable. Okay, which means you can inject values into these things. Okay, if you have worked on C, you know that in printf function you can have %d for data as in integer,
Yes,
percentage.
sir, but it means like a Python.
क्या लो
पाइथन में भी हम ऐसे ही करते थे, मतलब डॉट
एग्जैक्ट,
फॉर्मेट लगा के।
हाँ हाँ हाँ, करेक्ट करेक्ट। तो यहाँ पे तुम अपना ये सब इसको बोलते हैं प्लेस होल्डर, मतलब वो कंपाइल टाइम में एक मतलब एम्प्टी प्लेस रख देगा, जब तुम्हारा रन टाइम होगा उस समय वो इंजेक्ट होगा उसमें। ठीक है, तो ये
या ओके
बेसिकली
सर।
प्रिंटफ यूज होता है प्लेस होल्डर के लिए। जैसे यहाँ पे मैंने ये लाइन लिखा और यहाँ पे मैंने एक प्लेस होल्डर बना दिया कि एक वैल्यू आएगा जो तुम यहाँ पे इंजेक्ट करोगे, दैट्स इट। तो उसके लिए तुमको एफ चाहिए, प्रिंट एफ।
ओके सर।
इट बेसिकली स्टैंड्स फॉर प्रिंट फॉर्मेट। ठीक है,
या ओके सर।
any questions about this? Cool, I'll assume there are no questions. So we have learned these three things: map, flat map, filter. No, sorry, we learned map, filter, and listing. Now we'll learn about flat map. So what is the condition of, like, what is flat map? Flat map is nothing but map plus flattening. What do I mean by this? Let's see. You know that a map takes in basically it is a piece of function which works on a stream of elements. Okay, what do I mean by this? You have a stream, okay, of, let's say, elements. You feed it to a map, okay, and then you get a stream of whatever you have. Like, I'll put this thing here, so it will be decided at the runtime. This is what map function does. Okay, Abhishek, you were saying something?
Yes, sir. Sir,
Yeah.
I'm literally confused in map, sir. Using map function, you are still converting data type as a
हाँ, मतलब
integer to
यहाँ
string.
पे you can do anything you want. Like this gives you flexibility of performing some operation. Like if you want to change the data, or if you want to, like, let's
मैप
say,
फंक्शन कहीं और भी सर सभी जगह ये वर्क करेगा।
क्या क्या
सर मैप फंक्शन यदि मैं कन्वर्ट कर जैसे यहाँ से इस फंक्शन में सर ये लाइन
हाँ,
लाइन नंबर 48 में सर ये इंटीजर टू स्ट्रिंग ये कन्वर्ट हो रहा है।
करेक्ट
देन यूजिंग मैप मैप फंक्शन हम लोग कहीं और भी सर यूज कर सकते हैं
करेक्ट करेक्ट। तो तुम,
कन्वर्टिंग
हाँ,
में।
यहाँ पे तुम इधर आओ, आके तुम बोलो कि मैप, मेरे को जो वैल्यू मिलेगा, जो कि अब तुम्हारा स्ट्रिंग होगा, यहाँ पे देख सकते हो तुम, इसमें तुम और कुछ लगा दो ना, यहाँ पे तुम लगा दो कि वैल प्लस
नहीं
ए।
सर, एक्चुअली मैं ये कहना चाह रहा हूँ कि ये स्ट्रिंग फंक्शन के साथ ही मैप सिर्फ काम करेगा या अदर फंक्शन के साथ भी ये मैप फंक्शन काम करेगा?
नहीं नहीं नहीं, मैप मैप पूरा स्ट्रीम का है। तो ये जो स्ट्रीम देख रहे हो ना, ये तुम्हारा स्ट्रीम इज काइंड ऑफ लाइक कलेक्शन। ठीक है, तो जैसे
ओके
लिस्ट के ऊपर तुम अगर डॉट मारोगे तो तुम्हारे यहाँ पे ऐड, सब लिस्ट, रिमूव, ये सब फंक्शन आता है ना, ये कहाँ से आता है? ये सब तुम्हारा लिस्ट इंटरफेस नहीं तो कलेक्शन इंटरफेस से आता है। ठीक है, वैसे ही एक चीज है कि स्ट्रीम स्ट्रीम तुमको ये सारी चीज देता है। अप टू दिस पॉइंट तुम्हारा स्ट्रीम है। तो तुमको अगर मैप फंक्शंस के साथ काम करना है, मेक श्योर यू हैव अ स्ट्रीम, नहीं तो काम नहीं करेगा। डज दैट आंसर योर क्वेश्चन, या फिर स्टिल कंफ्यूज हो? बताओ, मैं एक्सप्लेन कर दूंगा। हेलो अभिषेक, आई कैन नॉट हियर यू।
नहीं क्लियर सर।
क्लियर हो गया? ठीक है, चलो।
हेलो यस
हाँ,
सर क्लियर सर।
ठीक है, ओके, ठीक है।
यस सर।
यार मेरा नेट खराब है क्या? एक मिनट। नहीं, ठीक ही तो है। ओके, मस्ट बी योर नेट। कूल, ठीक है। तो this is what map does. Okay, you can change it back to like, let's say you want to change this to something else. Let's say you want to say big decimal dot value of, अरे कहाँ गया? नहीं, इसमें तुम बोलो कि न्यू बिग डेसिमल। ठीक है, इसमें अगर हम लोग वैल पास कर दे, क्या बता रहे हैं? हाँ, इसमें प्रॉब्लम होगा बिकॉज यहाँ पे हम लोग 50 से बनेंगे, बस खत्म, ठीक है. तो see what we did here, okay? We mutated the data here, we changed this to this to this, ठीक है, and then we converted this string into something called big decimal, okay? So you can map gives you a lots of flexibility, like at this stage I changed it to stream of string. You can see here, let's say I want to change it back to integer, ठीक है. So what I'll say is integer dot parse int, I'll pass this val, ठीक है, which means that the next stream here, just ignore this thing for now, ठीक है, the next one here would be a stream of integer. Now let's say I want to add data to it, so I'll add one more map, ठीक है, I'll add one more map, I'll say val val plus सब सारे item के साथ 10 add करो, ठीक है, and then it gives me another string function. उसके बाद मैं बोलूँगा हाँ ठीक है, ये 10 add करने के बाद give me convert them back to let's say string. So what I'll do is I'll say map, ठीक है, कहाँ गया, हाँ, अरे यार, हाँ, ठीक है, we'll say map val we'll say string dot value of, ठीक है, and then we'll just pass the value here, ठीक है. You need to understand what is happening here, okay? Let's see. Stream, it converts to stream, then we filtered it, then we found out the distinct elements, then we applied these many map functions to transform the data muted. So here we changed the data type itself, then we changed it back to another data type. Here we mutated the data, as in we changed the value of the data itself, then here we converted back. You can do anything you want with map, okay? Cool. Let me find क्या था यहाँ पे, final list. This will give me back a list of string. So string, and I'll say final list. Done. Okay. So this was basically your map, filter, and distinct. Let's learn about flat map. So as I said here, flat map is basically map plus flattening, okay? What is map plus flattening? You already know what map is, but what the hell is flattening? Let's see. Let's imagine you have a list, okay, of list. Okay. What am I doing here? I'll say 1, 2, 3, and then 55, 56, 66, 23, 55, and then let's say this one just has 10. Okay. If when we have a list of list, or let's say you have a deeply nested thing, like you have list inside of a list or something like that, then you have to perform all of these operations, right? It becomes difficult because each list, each element in the list is a list itself. So that becomes very difficult to work with, right? So what you want at the end of the day is you want a single list which contains only these values and not these lists itself. That part is called flattening, okay? Which means that the flattening part will basically give you a map, but it'll look like this. Okay, that's all. That's all flat map is. When you're working with something of something, and you don't have access to the data itself, but you have access to, let's say, something else inside of which the data exists, then you have to use the flattening. This process is called flattening. It then becomes a stream, and then you can apply the map function on it. Okay. Yeah, Abhishek or Anish, who's this?
सारे को ऐड करके एक सिंगल जगह पे नहीं सर?
कौन सा?
फ्लैटरिंग सारे को ऐड करके एक जगह पे
फ्लैटनिंग
वैल्यू
सारे
स्टोर करेगा, मतलब सारे, मतलब जितने भी नंबर से सारे को एक जगह पे,
एग्जैक्टली सबको एक जगह पे करके फिर तुमको एक भेजेगा. ठीक है, तो मैं अभी दिखा दूं एग्जांपल यहाँ पे. तो what can we do here? Let's say we have a list of list, ठीक है, of integer. Let's call it L2. no array list. ठीक है, अब L2 में हम लोग कैसे ऐड करेंगे? We'll use the arrays library function. ठीक है, you can see arrays here, and then you have arrays. Arrays is coming from Java util class. Okay, which means this is all utilities given to you by Java guys. You'll say as list. ठीक है, here I'll add elements 1, 2, 3. ठीक है, and then I'll just copy this. What do I want here? 1, 2, 3, then 10, 10, 13. 10, 10, 13, then let's say 11, 11, 32, and let's say 200, 1 and 200. Okay, so this would be our list of list. If you want to see how it looks, you can just pass this list. Okay, now how do we do this thing? We'll say L2 dot stream, because we need to work with the stream API. So this is the first step, convert it to a string. Okay, stream. Then you say flat map. We can see this flat map. Okay, inside of this flat map we have a function called collection. This is called method reference, by the way. Okay, we have this thing, collection dot stream. Okay, which is essentially, basically what you're doing here is val dot stream. Okay, every item that you have here, every list that you have here will go out as a stream. So what the flat map will do now is it will first flatten this part, and then it will give you a single stream with all the elements inside of it. Then you can run your normal map function. Okay, for now what I'll do is I'll say val, I'll do the same thing, plus val. Okay, and I'll say dot collectors to list. When you say to list, it gives you a list of string. I'll just directly print this out. Okay. Okay. So what this will do for now, ignore this thing. I'll tell you why this is coming. But what this will do for now is it will basically print everything. You can see it here. Ignore these outputs. So look at this. Acha, after operation is actually coming here, is it? Right. I think we need to add a new line here. Confusing हो जा रहा है. ठीक है. This was our previous output. Look at this. So this was our initial data structure. It was a list of list 1, 2, 3, 10, 10, 13, all this stuff. Okay. Then what we essentially did was we just converted them to a string. So it now has a stream of strings, and you have every object here as a single list. Okay. And then after this point, you can start your, you can apply your same logic again. You can say filter, and then you can basically say any value that is whatever we have done here. So I'll just copy these two things. Okay, I'll do this, and you'll see the same output. Okay, you can see 2, 10, 32, and 200. Okay, that's it. So this completes our stream API basically. Okay. And stream API has a lot of other functions. It has map to int, map to double, and all those things. Those we'll learn as we start working with Spring Boot. But for you to be comfortable with those things, you have to learn how these things work. Okay. That's all for now. Let's take a 5 minutes or 10. I'll take a 10 minutes break, and let's meet at 9:10. If anyone has any question, they can ask me now, or we'll meet in 10 minutes. And then after that, we'll start with thread local. Okay.
सर एक बार कोड दिखा देना ऊपर.
कोड ये लो.
str के जस्ट ऊपर हल्का सा ये फॉरेन
कौन सा हेलो.
हाँ सर, हल्के से ऊपर.
किसके ऊपर बताओ?
वो str डॉट है ना, ऐड str list dot add जस्ट ऊपर सर.
अच्छा ये ऊपर ये वाला
Yes, sir.
हाँ तो बोलो यहाँ पे क्या समझना है
तो देखना था सर बस।
अच्छा अच्छा 9:10 को ऐड मीट करते हैं फिर से 10 मिनट्स ब्रेक Okay. We'll start with the next one. I hope everyone is back. So we'll start with this. Okay. Thread local. If we do have time, we'll explain this, or this will be part of spillover. Actually, let me just go ahead. Okay, so thread local. Let's talk about this. What exactly are thread locals? So you guys know that, yeah.
Sir.
Yep. Abhishek.
Explain, sir.
भाई तुम्हारा आवाज सुनाई नहीं दे रहा, तुम थोड़ा चैट में लिख दो. I'm watching it.
Hello. Okay.
हाँ, chat में लिख दो. Okay. So you know that Java is a multi-threaded programming, right? What it means that you have a main thread. Okay. This might make you confusing. Okay, let me explain what happens. So you know that our CPU today runs on multiple cores, right? We back in the days we used to have a single core. So please explain coding part again. Okay. All right, Abhishek wants me to explain the coding part. Okay, I'll start from the beginning.
Not sir, beginning, not beginning, sir.
Then
end, sir, end, last end.
ये वाला part?
Yes.
This part?
Yes, sir. Flat map part, sir.
Flat map वाला part ना, ठीक है.
Yes, sir.
अच्छा, हम लोग यहाँ पे क्या लिए? हम लोग यहाँ पे एक सिंगल लिस्ट के साथ डील कर रहे थे ना. यहाँ पे बस एक सिंगल लिस्ट, उसमें हम एलिमेंट्स डंप करते जा रहे थे. क्या करोगे जब तुम्हारे पास एक ऐसा लिस्ट है जो जिसके अंदर हर एक एलिमेंट itself is a list, ठीक है? तो तब तो तुमको अगर तुमको ऐसे कोई डेटा के साथ काम करना पड़ेगा, ठीक है, जिसमें तुम्हारा इट्स अ लिस्ट ऑफ लिस्ट और इट्स अ मैप ऑफ लिस्ट और इट्स समथिंग ऑफ समथिंग, ठीक है? जब डीपली नेस्टेड एलिमेंट्स है ना तुम्हारे, यहाँ पे जो 1 2 3 है वो डीपली नेस्टेड है, वो एक लिस्ट के अंदर है जो कि एक बड़ा वाला लिस्ट के अंदर है, ठीक है? तो ऐसे डेटा के साथ काम करने के लिए यू हैव टू मेक दिस डेटा अवेलेबल. मतलब तुमको ये सारी चीज जो है इसको यू हैव टू कन्वर्ट इनटू समथिंग which looks like a list itself. तो हम लोग इसको अगर पुराने वे, मतलब if we start doing this the old way, तो हम लोग क्या करेंगे, हर इस लिस्ट के ऊपर आइटरेट करेंगे एंड फिर हर एक लिस्ट के मतलब फॉर लूप चलाएंगे, उसमें अंदर हम लोग एक एक एलिमेंट मतलब एक एक लिस्ट होगा, फिर उस लिस्ट के अंदर हम लोग और एक फॉर लूप चलाएंगे एंड वो हर एक एलिमेंट हम लोग पिक करके एक फाइनल लिस्ट में डाल देंगे. उसके बाद हम लोग ये ऑपरेशंस करेंगे, ठीक है? यू कैन डू दैट और ऑल ऑफ दैट कैन बी डन बाय फ्लैट मैप, ठीक है? फ्लैट मैप बेसिकली क्या करता है, वो तुम्हारा ये चीज को लेता है एंड वो उसको फ्लैटन करता है, ठीक है? मतलब वो बाहर के जो रैपर है, ये जो तुम्हारा ये अंदर का जो लिस्ट है एंड बाहर का जो लिस्ट है, वो सबको हटा के वो बस तुमको ये एलिमेंट्स दे देता है, ठीक है? समझे तुम फ्लैट मैप का फंक्शनैलिटी? ठीक है. अब फ्लैट मैप अगर हो गया तो उसके बाद हम लोग आराम से हमारा जो प्रीवियस ऑपरेशंस था कि एक तुम फिल्टर करो, उसके बाद तुम डिस्टिंक्ट एलिमेंट फाइंड करो, उसके बाद तुम कन्वर्ट करो डेटा को इंटीजर से स्ट्रिंग, वो करे, ठीक है? एनी कंफ्यूजन अबाउट फ्लैट मैप?
No, sir.
ठीक है,
sir.
cool. So let's talk about thread locals, ठीक है? Okay, before we talk about thread locals, let me give you a little bit of information about what threads are and why threads are there, ठीक है? तो in today's world, we have multi-processing programming and we have multi-threading programming. Okay, this is actually an interview question, the difference between multi-programming, multi-threading and multi-processing. Okay, so what is multi-processing? You have different processes, different cores in your system, like quad-core computer, dual-core CPU, okay, octa-core CPU. These are each units, okay? Each unit that can perform one single operation. When I say perform one single operation, that means they can execute one single instruction. I don't think you guys are familiar with the machine level coding, as in like the assembly level code language, but something as simple as this, right? If you guys are from the engineering background, you would know that something as simple as this, okay? something as simple as this, right? In the machine's assembly language, it would look something like this. Load A into register, sorry, load A into register something 1, 2, 3. Okay, and then load B into register 2, 3, 4. Okay, these all map to own memory addresses, which is basically the registers. Okay, this is how close your assembly language looks like. Then you would basically say add like register 1, 2, 3, and then this, and then you would say load result in C. Okay, don't worry about this. I'm basically showing you that if we perform something as simple as this, a single Java line code like this can actually turn into multiple instructions in the machine coding round. I mean, in the machine at the machine level language, which is also known as assembly language. Okay, so when I say one code executes exactly one instruction in 1 microsecond or millisecond, I basically mean one command like this. Okay, so let's say you have another, this is a Java program which does this. This is a C++ program, okay, which basically says 2 plus 2. Okay, so what can happen, how actually it happens in a single core machine is that they give you time slices. I'm not sure if you're so this is basically a bit of computer science concept. If you have a single core machine, maybe this instruction, so if you have a single core machine and let's say these two instructions take, let's say 10 seconds time, okay, and those 10 seconds can be split into 1 second, 1 second, 1 second, like that, 10 times of 1 second. Or if you like split even more, like microsecond, then you can have lots of slices. These are called time slices. So what usually happens on a single core machine is, let's say these are your slices. Okay, let's say you have 5 seconds or 5 slices. Let's say in the first second the Java program executes on a single core. Then in the next slice, C program executes. Then in the next slice, J program executes. Then in the next slice, C program executes. Like this, the processor, the single core, basically keeps switching between contexts. Okay, this is at the OS level, the operating system level. Okay, now Java runs on a virtual machine. Java never really talks to your actual OS. Okay, so in order for Java to perform something like this, the concept of thread was introduced. Okay, Java threads are basically how do I say? These are like small Java programs within itself that have their own memory in the virtual memory, and then they actually talk to your OS using the JVM. Okay, so that's basically what threads are. Thread in essence is just a single unit of work. It's a program in execution. That's the definition of thread. It's a program in execution. Now you can do all the work in a single thread. Okay, you have to, let's say you want to do a transaction on a bank. So first they have to fetch your bank balance, then they have to check what is the amount you're asking for, then they'll do the deduction, then they'll deposit. All of these things can happen in one single thread, or you can do it in multiple threads. Okay, so this is where the concept of multi-threading comes in. You have a single thread that can do all of those things, but what usually happens is, if you have a single thread and then one task takes too much time, then all the other operations or the tasks will have to wait until that single task is done. That's why we came up with the idea of cores. We also came up with the idea of threads. Okay, so if your machine has 4 cores, or if your machine has more than 1 core, that means at any given time 2 instructions can execute at the same time. Okay, now if your programming language, let's say if Java was just a single threaded language, right, then you're only going to be using one single core. You're not going to be utilizing the machine's other cores, which means when your Java program is running, right, and let's say the Java program has given a time slice, within that time slice, the Java program, if the Java program is a single threaded language, then it will just work with one core and the other core will be sitting dumb. Okay, In order to avoid that, Java introduced the whole thing of threads. Okay, threads basically are single units of work which can perform parallelly. Okay, any questions about threads?
No, sir.
Okay,
No, sir.
cool. So then when you have a thread, you have so when you start working with in a multi-threaded programming language, the biggest problem of a multi-threaded environment is shared object. Okay, what I mean by this is, let's say there are two threads, T1 and T2, sorry. Okay, and they are basically going to, they have a value called C, which is 0. Their job is that this guy will run 5 times. This guy will, like, let's imagine that this thread has basically a loop which runs 5 times. This thread has a loop which runs 5 times. What happens in each loop is the value of C gets incremented, which means from 0, it will become 1. Then from that, it will become 2. Then from that, it will become some other value. Okay. Similarly, the same thing will happen here. Now, this is a shared variable. This is something that is shared across T1 and T2, right? And if you have a single core machine, right, then this multi-threaded problem won't be there because it's a single core. If T1 is using C at that point, then T2 will have to wait. But when you go into a computer which has more than one core, that means there are now 2 cores, which means you now have capabilities of doing the same thing twice. Okay, in many cases what happens is, if everything goes well, then at the end of this function your value should change from C0 to 10. Okay, but it usually doesn't happen. There is a condition called race condition, okay, which often results in irregular values. Like you could have 6, you could have 5. Okay, it would not be 10. Why does that happen? Because this shared variable is being used by both the threads at the same time. So if T1 is reading C at this point, he's reading C as 0, and this guy is also reading C as 0. So they both increment it as 1. Okay, then let's say this guy reads 1 and then converts it to 2. And at this point, when this guy wants to do it, he also reads 2. Okay, this is called race condition because you now have 2 threads competing against one another. Okay, in order to avoid this thing, so this any question, anyone? No. Okay, so this entire condition, this whole idea of sharing a variable introduces something called thread safety. What is thread safety? Thread safety basically means how safe is an object from this race condition. What is thread safety? It basically says how safe is an object from a race condition. Okay, what we expect is, if 2 threads are working with C and they're both running 5 times each, the value, expected value, should be 10 and nothing more than that, nothing less than that. Okay, so there are many things you can do to ensure thread safety. You can put a lock on this thing. You can lock this C, which means that if this guy wants to work with C, he will have to unlock C first. And while this guy is working with C, this guy will have to wait. Okay, even if it's 2-core processor or let's say 16-core processors, if there is a lock on C, they will do it. This is one way of handling thread safety. Okay, when you start learning about multi-threaded programming, you'll see many different ways of handling thread safety. One of the ways to handle thread safety in Java is called thread local. Okay, what is the idea behind this thread local? It basically says that I'm going to give you a wrapper object, okay, in which you will put your object, and it is going to be only local to that thread, which means this thread local here, let's say it contains a value str. We don't know what the value is. Okay, T1 comes and it changes the str to, it assigns this value A. Okay, T2 comes and it assigns the value str to B. Okay. Then when this guy reads it, when this guy reads the string, thread local guarantees that it will read A and not B. Similarly, when this guy reads it, thread local guarantees that it will read only B and not A. Okay, that is the whole idea of thread local. It makes this string object, it makes this string thing completely invisible to these two threads. Like if this guy is using its str, this str is not visible to this guy. This str is not visible to this guy. I know this is confusing, so ask me now if you want me to explain again before I go into coding. I'll explain this again, okay? This condition is called a race condition, wherein let's say this value changes to 2, and when this guy is trying to increase, it becomes 3. Okay, this is a race condition because these two guys are competing for the same resource. There are many, so this entire, so we have to see how thread safe C is from these two threads. Okay, so in the concept of thread safety, there are many ways you can make one item or one method thread safe. One of the ways is thread local, the other one is lock, and there are many different ways of making something thread safe. So we're basically dealing with thread local. What happens in thread local is, this is an object in Java which says that if you're working with something, if your thread is working with this thread local, then whatever this thread puts into this thread local will never be visible to this guy. Whatever this guy puts into thread local will never be visible to this guy. Okay, this is what thread local does. And now we'll see how it actually happens. Okay, so let's say I'll create a simple okay, I'll create this class called what can I call this thing? Name store. Yeah, name store. What it will do is it will store a list of names which are strings. Okay, so what I'll do here is I'll say private static final. You have this thread local class. Here you will say list of string. Okay, I'll call it name store. You can see that these are all generics here. The thread local, this is a generic, and then list itself is a generic. Okay, that's a new thread local. Okay, now I'll expose 3 operations here. Okay, first is I will add an element to this. I will initialize it, and then I will add it to the I'll add elements to it, and I'll remove elements from it. Okay, so public static, and this class is all the methods are going to be mostly static because this is one single, it's kind of like a library class or utility class. Nobody has to create name store equals to new of name store. No one will have to do that. They can just go ahead and start using the method itself. Okay, so public static, let's say I want to add I want to init this thing. Okay, so I'll say void init. Okay, what this will do is it will say final list of string L new array list. Okay, and then I'll say name store dot set. Acha, let's not do that now. Let's do this. Let's just put simple setters and getters. Okay, so I'll say public static void set name store. Okay, this will take a simple list of string name store dot set list. We want the name store back, so I'll say list okay, and I'll also provide a method here to basically clear everything out. So if I'm static void clear all, which will basically take the name store and it'll say remove. Okay, let's see what's happening here. This is a normal simple Java class. Okay, if you ignore this part, this is a setter method setting the name store. It's taking a list and it's setting it inside this. This is basically getting this same list back, and this is actually removing this list altogether. That means from this whatever memory that this guy occupies, it basically empties that memory by calling this remove function. Okay. So what is thread local? I told you that a thread. This is going to ensure that if there are multiple threads, each thread sees its own value and not the other value. Okay. Yeah. So let's now go ahead and create something called Runnable. So what is a Runnable? Let's talk about that first. A Runnable is basically a unit that your thread is going to execute. Okay. What is that? It is a function that you can pass to your thread, and your thread will only execute that, which means inside your Runnable, you're going to implement your logic. Okay. So you can see here, you have something called Runnable, include projects. You can see that you have an interface, which is again a functional interface. It is Runnable, and basically it has a single run method and it doesn't return anything. Okay. So how do we do this thing? First thing I'll do is I'll create a Java class. I'll call it let's do the Lambda way. Okay. I'll call a main class. I'll say final Runnable my Runnable. Okay. This is the Lambda expression. Here I'm just gonna, let's just see how thread works first, then we'll work with the thread local. Okay. Hey, I am, and then there's something called thread. I'm gonna get the current thread's name. So I'll say current thread, not get name. Okay, don't worry about these methods. I'll just tell you what it is. Or if this is confusing too, I am running. Okay. This is just Runnable. And when you create a thread, you can inject a Runnable into it. So I'll just say thread. So thread is the class that is responsible for creating a thread in the JVM, okay, which then talks to your actual OS thread or the core. So thread, I'll call it T1, new thread. Here you can see the first parameter is no parameter, then the second one is Runnable target. So I will basically pass this my Runnable here. Okay, done. Then I'll create one more thread here, T2. I'll say my Runnable. So they're both going to execute the same thing because it's the same thing I want to print. Okay. If I wanted to have something else, I could have passed another Runnable. We'll see that. So now if I just run this thing, you will see this thing. No, sorry. In order for you to actually start this thing, you have to call this method called start. So on the thread, you call the T1.start and here you call T2.start. Okay. If you do this thing, you can see that this is actually coming twice. So how do you know which thread is running this thing? Okay. So in order for us to know which thread is running, there are two ways we can do this thing. We can create this thing. Hi, I am running T1. Okay. And then copy the same thing. Okay. I'll call it my Runnable 2 and you can say thread 2. Okay. And in this one, I'll just pass the 2 and I'll start. So far, I haven't touched upon what I created in thread local. Okay. You can see that, hey, I'm running T1 and hey, I'm running T2. They're both executing parallelly. Okay. Now, you can either do this or you can use the single thing, and you just need to know you just need to find out the name of this So you can say plus thread, the same thread class that you just created. It also has some static methods. You can call current thread. This will give you the thread that is currently executing, dot get name. Okay, and if you run this thing, okay, you can see. So if you do not insert any name into your thread, this is the default name that will get there, thread 0 and thread 1. Okay, so what happened here? I created a runnable. What is a runnable? Runnable is what the thread will do internally. Okay, so you create a runnable. You could create 2 different runnables for 2 different threads, or 100 different runnables, or 100 different threads, or you can create a common runnable and pass it on to your thread. Okay, so far there is no concept of thread safety. Nothing is happening here because I'm not trying to use a shared variable here. Okay, this is not a shared variable. It's just a simple thing that actually implements something. Like actually, it has its own functionality and it just executes. The problem occurs here when you have something like this. Let's say private static integer count equals 0. Okay, when you start using this, okay, right here, what happens is this is now a shared variable. Why? Because in the memory stack, the main thread already has a reference to this. Like this is already occupying some memory in your JVM, right? And these two guys are basically sharing this count across them using this runnable. So there is a possibility of a race condition. If we run this thing, I'm not sure if we'll see race condition immediately. 0 and 1, current value is 0 and 1. Okay, but if you have like multiple threads, sometimes you can see that it actually goes to, like you can see here, so yeah, let me just see which thread. 1 second. Let me just see which thread is executing what. Okay, maybe that will make things. Okay, so thread 1 is actually incrementing this to 0 to 1, and so for these things, because mine is a multi-core machine, you may not run into the race condition. So, but there are possibilities and there are scenarios where race condition happens. This is guaranteed to give you a race condition because you're now using a particular variable in the memory which is shared across these two things. So in order for us to basically not have something like this, to avoid the problem of sharing across variables, we introduced thread local, which basically says that whatever you use inside me will always be yours and no one else can see it. So let's see how we can use this thread local. Okay, so okay, I'm gonna have to create a runnable here. Let me think, what can I do with this runnable? The first thing is it will basically insert a value, and then it'll insert a list of values, and then it'll basically it'll wait for a few minutes, and then it'll remove a value. It'll again wait for some minutes, and then it'll print something. So what do we do here? We say final runnable. Okay, what are the things? First thing is I'm going to initialize a list. Okay, so let me just create this list here. Final list of strings list, new array list. Okay, and let's actually put a value here. Okay, string list dot add common val. All right, let's see how this works. What I'll do here is in this is wrong. Okay, in this what I'll do is I'll say string list. I will initialize this thread local. Okay. I directly use this thing. Okay. So I will use this name store dot set name store. Okay. This is the first thing I'm doing here. So I'll say setting the name store. Okay. And I want to print out the list at this point.
Hello.
Yeah.
Sir, actually, can you explain again, sir, thread local part, sir? Because what's happened going on, I can't understand, sir.
अच्छा
कुछ समझ में नहीं आ रहा, सर.
ठीक है. तुमको ये पता चला ये क्या होता है? तुमको थ्रेड्स के बारे में कुछ पता है? ये पता है ना कि क्या होता है रेस कंडीशन? तो रेस कंडीशन अवॉइड करने के लिए हम लोग यहाँ पे क्या करें? हम लोग यहाँ पे जो C है वो हम लोग शेयर कर रहे हैं अक्रॉस दीज टू वेरिएबल्स. ठीक है. जैसे कि हम लोग यहाँ पे जो काउंट है वो काउंट हम लोग इस दो थ्रेड्स में शेयर कर रहे हैं. ठीक है. तो अभी तो यहाँ पे सब ठीक ठाक चल रहा है, बट देयर इज ऑलवेज अ पॉसिबिलिटी कि ओवरलैप हो सकता है. मतलब ये इंक्रीमेंट 0 to 1 ना होके ये कुछ और हो सकता है. ठीक है. एक्चुअली तुम अगर देखो ना यहाँ पे वैल्यू तुम्हारा यहाँ पे हाँ नहीं ये ठीक है. तो 0 1 एंड जो इंक्रीमेंटेड वैल्यू है वो 2 है. बट कभी कभी ऐसा होता है कि एट अ टाइम दो थ्रेड्स सेम चीज को रीड कर रहे हैं, 0 को रीड कर रहे हैं, एंड देन वो लोग दोनों उसको एक इंक्रीमेंट करके 1 बना रहे हैं. ठीक है. तो वो चीज अवॉइड करने के लिए हम लोग बहुत कुछ कर सकते हैं. थ्रेड सेफ्टी के ऊपर पूरा एक बुक लिखा हुआ है. तो उसमें हम लोग बहुत सारी चीज कर सकते हैं. हम लोग लॉक लगा सकते हैं, हम लोग इसको लोकल बना सकते हैं, वगैरह वगैरह, टन ऑफ थिंग्स. एक चीज जो है, one of the ways of doing this is called thread local. ठीक है. thread local basically जावा का एक इनबिल्ट क्लास है जो तुमको ये बोलता है कि तुम जो वैल्यू इसके अंदर डालोगे, ठीक है, एंड मान लो तुमने एक थ्रेड लोकल बनाया, उसके अंदर तुमने कुछ वैल्यू डाला और वो चीज तुमने सब में बांट दिया, मतलब 3-4 थ्रेड्स में बांट दिया. ठीक है. तो उसमें जो थ्रेड उसको जिस पॉइंट पे एक्सेस करेगा, ठीक है, उसको उस थ्रेड को वही चीज दिखेगा जो वो खुद उस थ्रेड लोकल के अंदर डाल रहे हैं. ठीक है. लेट मी रिपीट दैट. अगर तुमने एक थ्रेड लोकल बनाया, इसको एक्चुअली हटा देते हैं, मे बी दिस इज कंफ्यूजिंग यू, लेट मी रिमूव दिस, लेट मी जस्ट कीप अ स्ट्रिंग हियर. ठीक है. एंड यहाँ पे हम लोग बस एक स्ट्रिंग लेते हैं, चीजें इजी हो जाएगा. ठीक है. ठीक है. ठीक है. एंड यहाँ पे हम लोग बस एक, ठीक है. ओके. तो थ्रेड लोकल बेसिकली क्या बोलता है कि तुम यहाँ पे जो चीजें डाल रहे हो इसके अंदर, वो बस मतलब उसका स्कोप बस तुम तक है, उसको बस तुम ही एक्सेस करते हो, तो और कोई एक्सेस नहीं कर सकता है. अगर T1 इसको एक्सेस करे एंड मान लो T1 ने यहाँ पे अपना नाम डाला thread 01, ठीक है, तो जब वो रीड करेगा उसको thread 01 ही दिखेगा, उसको और कुछ नहीं दिखेगा. इसमें प्रॉब्लम क्या है कि यहाँ पे ये जो शेयर्ड वेरिएबल है, ये शेयर्ड वेरिएबल तुम्हारा कभी भी चेंज हो सकता है. मतलब यहाँ पे अगर 500 थ्रेड होता एंड ये लोग हर एक थ्रेड इसको एक पॉइंट करके इंक्रीमेंट कर रहे हैं, चांसेस आर कि तुम्हारा मशीन में अगर मल्टीपल कोर है तो वो 500 ना हो के वो 499 या फिर कुछ एक गार्बेज वैल्यू ऐसा आ सकता है बिकॉज ऑफ रेस कंडीशन. ठीक है. तो रेस कंडीशन अवॉइड करने के लिए हम लोग ये थ्रेड लोकल का कॉन्सेप्ट यूज करते हैं. उसमें हम लोग ये बोलते हैं कि अगर तुम यहाँ पे कुछ रख रहे हो, इफ यू इंसर्ट अ वैल्यू इनटू इट, इट विल ओनली बी अवेलेबल टू दैट पर्टिकुलर थ्रेड, व्हिच मींस कि इवन दो दिस इज अ स्टैटिक क्लास. ठीक है. ये देखो तुम एक स्टैटिक क्लास है, मतलब अगर ये थ्रेड इससे यहाँ पे यूज कर रहे हैं तो वो बेसिकली ये स्टैटिक मेथड कॉल करके यूज करेगा. कहाँ गया? हाँ, ये नेम स्टोर डॉट सेट नेम स्टोर. अगर तुम जाओगे, हम लोगों को क्या पता है कि स्टैटिक जो कोई भी अगर चीज स्टैटिक होता है, इट एग्जिस्ट ओनली वंस, इट एग्जिस्ट थ्रू आउट द क्लास. ये हम लोग इसका ऑब्जेक्ट बना नहीं रहे, तो जो स्टैटिक में है उसका बस एक ही इंस्टेंस है मेमोरी में. ठीक है. विच मीन्स अगर देखा जाए तो इट्स अ शेयर्ड वेरिएबल. ठीक है. इतना तक डू यू एग्री टू टिल दिस पॉइंट, अभिषेक? Sorry?
We are giving the multiple. Sir, हम लोग यहाँ सेट कर रहे हैं.
तुम थोड़ा
हेलो.
हाँ, सुनाई नहीं दे रहा था उस टाइम पे. ट्राई करो अभी बोलना फिर से. नहीं भाई, you have you it's better if you type it out, man.
Yes. Hello.
Hello, type it out, man. Okay, so let me repeat this again. Okay, this will be a bit confusing for you guys because probably you guys are not familiar with the whole concept of thread, but basically just understand that multiple threads, when they're working with, when they're sharing a variable among them, when they're tossing a variable, like एक हाथ से दूसरे हाथ जा रहे हैं ना, तो there is a chance के both the threads are accessing the variable at the same time, ठीक है, which means अगर thread 1 C को 0 से 1 बनाने का कोशिश कर रहे हैं and at the same time thread 2 C को 0 से 1 बनाने का कोशिश कर रहे हैं, instead of becoming C value becoming 2, it will become just 1 because both of them are actually trying to access the same thing. So there are many ways in which with the help of thread local we are giving priority. नहीं, priority नहीं दे रहे, there is no priority. इसमें प्रायोरिटी का कोई चीज नहीं है. थ्रेड लोकल बस तुमको यही बोलता है कि पहली बात तो है यू नीड टू अंडरस्टैंड कि स्टैटिक क्या चीज होता है. इफ यू नो व्हाट स्टैटिक इज, एक क्लास में जो तुम स्टैटिक किसी भी चीज को अगर तुम स्टैटिक बोल के डिक्लेयर करते हो तो वो पूरा जेवीएम का जो मेमोरी तुम्हारे ऐप को दिया जाता है उसमें बस एक ही इंस्टेंस, एक ही मेमोरी स्पेस वो ऑक्यूपाई करता है स्टैटिक. ठीक है, इसका मतलब ये है कि तुम अगर किसी भी क्लास से उसको एक्सेस करो, यू आर एक्सेसिंग द सेम मेमोरी एड्रेस. ठीक है, विच मीन्स दैट अगर तुम ये चीज मल्टीपल थ्रेड्स में बांट रहे हो, ठीक है, तो ये वही सेम मेमोरी एड्रेस को एक्सेस करेगा. इसको हम लोग, विच मीन्स वी कैन कॉल दिस थिंग अ शेयर्ड वेरिएबल. ठीक है, शेयर्ड अक्रॉस द एप्लीकेशन. ठीक है, अब जब हम लोग शेयर वेरिएबल के पास, मतलब व्हेनेवर वी डील विद शेयर वेरिएबल, तभी ये रेस कंडीशन का प्रॉब्लम होता है. वो रेस कंडीशन थ्रेड लोकल टेक्स केयर ऑफ दैट. थ्रेड लोकल बस ये बोलता है कि गिव मी द ऑब्जेक्ट एंड आई विल गिव यू अ रैपर. थ्रेड लोकल, इफ यू सी, इट्स बेसिकली अ रैपर ऑन स्ट्रिंग. ठीक है, तो यू नेवर हैव एक्सेस टू दिस पर्टिकुलर गाय एवर. थ्रेड लोकल does not give you access to this, it just gives you access to the wrapper which is itself. ठीक है, तो internally thread local works in such a way that whichever thread calls this thread local, even though it's a static member and even though in the application memory there is exactly one instance of this, ठीक है, multiple threads when accessing it, they will only see the values they put in there, they'll only read the values they put in there. Okay, is this clear to you what thread local does? I'll come to the implementation part later, but you need to be thorough with the concept of what thread local does. Just type it out here if you understood or not, Abhishek. Not clear. Acha, what part is not clear? Part is not clear. Thread local working part. अच्छा, ठीक है. Okay, how do I explain this? Let me ask you a few questions. Do you know that static variables are like only a single instance? Yes or no? Just type yes or no. That if you declare static, it exists on the class level. That means in the entire application, it occupies only single address space and that's it. Do you agree with this? Yes or no? Yes. Okay. Cool.
Sir, can you repeat, sir?
हाँ. Basically मैं जो बोल रहा हूँ कि ये मैं बोल रहा हूँ कि अगर तुम कोई static member के साथ deal कर रहे हो, ठीक है, if you have some static variable, तो do you agree कि वो static variable it exists only in one single space? Like जैसे हम लोग अगर new कुछ बनाते हैं ना, let's say we create object equals new of object, तो वो memory space में एक अलग मतलब एक memory में वो एक अलग space acquire करते हैं. But जो भी static variables है ना, वो बस class level पे exist करते हैं. मतलब उस class को एग्जिस्ट करवाने के लिए जितना मेमोरी स्पेस चाहिए उसी के अंदर वो स्टैटिक वेरिएबल्स एग्जिस्ट करेगा। अब उस क्लास से तुम जितने सारे ऑब्जेक्ट बनाओगे वो सारे ऑब्जेक्ट अलग अलग मेमोरी स्पेस ऑक्यूपाई करेगा, बट जो स्टैटिक फील्ड है वो क्लास के मेमोरी स्पेस में एग्जिस्ट करेगा। मे बी वेट, ठीक है, एक बार फटाक से कर देता हूँ तो शायद समझ में आ जाएगा।
Common for all objects.
Exactly, it's common for all objects. हाँ ठीक है, okay, pay attention to this. Imagine this is your Java applications memory space, ठीक है। इसमें हम लोगों के पास एक क्लास है, क्लास A, ठीक है, इसको हम बोलते हैं क्लास A। उसके अंदर एक वेरिएबल है, स्टैटिक वेरिएबल, जो है नेम, ठीक है। अब तुम इस क्लास से जितना ऑब्जेक्ट बनाओगे ना, obj a1, ठीक है, तो मान लो ये नेम तुम्हारा स्टैटिक है, ठीक है, और एक है तुम्हारा वैल बोल के जो इंटीजर है वो नॉन स्टैटिक है। तो अब बताओ अभिषेक के ये यहाँ पे अगर ये इतना मेमोरी स्पेस ले रहे हैं एंड ऑब्जेक्ट A1 ऑब्जेक्ट A2 अगर यहाँ पे क्रिएट करे, तो ये यहाँ पे कौन सा वैल्यू मतलब which member variable will be occupying space here and which member variable will be occupying space here, इतना बताओ बस, मतलब टाइप कर दो। दो बेसिकली वेरिएबल है, एक है नेम और एक है वैल। कौन सा वेरिएबल यहाँ पे रिसाइड करेगा एंड कौन सा वेरिएबल यहाँ पे रिसाइड करेगा? Okay, never mind. This is basically okay. So just type your answer, but let me just explain. So what happens usually is this is where your val will exist. This is where your val will exist. Okay, but this is where your name will exist. Okay, because name is a static variable, which means that regardless of how many objects you create, they will all share the same thing. Okay. Now imagine in the same way, your count here is something that is shared across both the threads. The threads have their own memory space, but when they deal with count, they basically deal with this shared memory space. Okay, so I'll change this to count here. Okay, I'll change this to T1, sorry, T2 and T1. ठीक है, अब कैसे थ्रेड लोकल काम करते हैं? ठीक है, there are many ways you can make sure that this count stays like the race condition avoided in this case. But what thread local does is it basically says that let's say this guy sets the value as 2 here. ठीक है, if this guy sets the value as 2, and then it reads the value. ठीक है, if it sets 2, then when it's reading it, thread local, what it basically does, let me just say this, thread local. Okay, it's a static variable, right? Thread local, you see here, I have defined this to be a static variable. Okay, but the magic behind thread local is if this guy is setting this value to 2 and it's reading 2, I mean when it reads it will only get 2. Let's say this guy is setting is at 2 and then this guy Okay. So let's say both of these guys, right? I'll delete this for now. Both of these guys are setting a value here at this point. Because this is a static variable, it is shared across both these threads, right? So in a normal scenario, if this is setting 2 and this is setting 3, it is going to replace the value here because static exists only once. Okay, then whichever reads first, if this guy is reading after setting it, it set 2 but it will read 3. Okay, if this guy is setting 3, it will read 3, but for this guy it's an error. Okay, this is what a race condition basically is. It overrides that thing. But if you have something called thread local guarantees that if two threads are accessing a variable at the same time with different values, okay, when they're reading those values, they will always guaranteed to read the exact same value that they put there. As that means if T1, let's say, put value 2 there, when it reads, it will always get 2. T2, even if let's say on the 10th second, or let's say on the 5th second, this guy pushed 2 into it and this guy pushed 3 into it, when they're reading it, if on the 6th second these two guys read, they will not read the same value, they will read 2 different values. That means if this guy reads, they'll get 2. If this guy reads, they'll get 3. Is this clear, Abhishek, what thread local does?
Yes, sir.
Right? Cool.
Right, sir.
Cool. Okay, so that's what thread local basically does. So what we have done here is we have created something called thread local, which is static, which means in normal scenario, if we didn't have thread local, this would have been overwritten, right? But we have wrapped our value inside string thread local here. So what it will do is you're inserting the value here, and this is just basic setters and getters. Okay, let's see how we actually use this. So in my runnable here, let's get rid of this. I will share the same runnable, or maybe I'll write 2 different runnables. Okay, so I'll say runnable 1 here. What I'll say is I'll say I'll do a couple of prints. Okay, actually I'll do print f. Okay, what will I do here? I'll say ampersand s is setting the name store. Okay, and I'll say thread dot current get name. So, or just let's just, because these are 2, let's just say T1 is setting name store. Okay, what do I want here? Change it to ln. Okay, then what I want to do is I want to set in this thing. So I'll say name store dot set name store t1. Okay, this is the string that they're setting. Now I will basically sleep. I'll make this thread wait for 5 seconds. Okay, so I'll say thread dot sleep. Okay, for 5 long value would be 5000. Okay, this will produce 5 milliseconds of this thing. I'll have to again wrap this with try catch as usual. Okay, done. After this thing, after this has waited for 5 milliseconds, all it'll do is it'll read the value. Okay, so I'll say sysout. Okay, and I'll basically read this value. So I'll say name store dot get name store. Okay, done. Okay, this is what it'll do. Anything else? Yeah, that's it. And this does not return anything. This is my runnable 1. I'll copy the same thing. Okay, I'll create one more runnable. Okay, this will be runnable 2. This will be thread 2. The only difference is that this will be printing a different message and it will be printing T1, T2. Actually, for us to understand, I have to know which thread is reading, right? So I'll say T1 reading. Okay, and then let me explain what I just did now. I have I'm printing the log here. I'm creating 2 different runnables for 2 different threads here. Okay, I'll get rid of this array list. It's not of use. Okay, what's happening here? You have T1 is setting name store, and then name store set is T11. So this guy is basically setting the static variable to T11, and then it's waiting for 5 seconds, and then it's waking up after 5 seconds and it's reading the value. Okay, this guy will not wait for 5 seconds. This guy will actually wait for, let's say, 3 seconds. Okay, a T2, and then it'll say T2 reading and then name store. Done. Okay, I'll pass this my runnable 1 to this guy, and I'll say runnable 2 to this guy. Okay. Now, ideally, if we did not have the concept of thread, actually, let me show you what happens without thread. Okay, let me get rid of this thread local here altogether. Let me show you how it works without thread first. Then you will know what I mean. This is string name store. Array. Okay. Acha, this cannot be final, so I'll just make it this. Okay. What happens here is you just say name store instead of this. You say name store equals this string, and instead of this, you would just say return name store, and then just get rid of this. Okay. Is there any problem? Yeah. Okay. So this is, I'm not using thread local at this point. Let's see what happens when I don't use thread local. So I'll come here, I'll execute this method now and run main. Okay. So first thread that got executed was T1. Okay. So first guy, he was the one who said who executed. T2 is setting name store, T1 is setting. So far both the threads started equally. Okay. Then let's see what happened. T2 is reading T1, and T1 is reading T1, right? So somewhere it must have been, somewhere there must be an error, right? So yeah, can anyone tell me what happened here? You see that the value got overlapped, right? T2 inserted T2 value, but then when it read, it got T1. Okay, let's see how we take care of this thing with the thread local. Okay. Make sense? T2, it read the value it inserted. T1, it read the value it inserted. This is what thread local basically does, even though they're both static methods here, right? Thread local ensures that if it's a shared variable, it will never get overlapped. Whatever value you're putting into it, it will always be the same. We will see, when we start working with Spring application, we will see the implementation of thread local. There won't be something called thread local. You will have something called security context, or something like application context. Okay, these things will be using thread local concept. So any questions here so far? In this case, in the previous case, when I just use a static string, one value was being overlapped, right? Thread local is, it's kind of like something which, if you insert a value to it, then only you can read that value. No one else can do it. Okay. Let me know if you have any questions over thread local. I understand it got a little confusing for you guys, but let me know and I'll explain again. Okay. So if there are no questions, then this is all. I think we have run over the time, so we'll explain the method reference thing in the next session. Okay, I'll basically copy this thing and just spit over. Even though this wasn't actually planned, but yeah. Let me know, guys, if you have any questions. Cool. If no questions, we can leave the session. Good night.